One reason that we use 4x4 matrices to store transforms is that a single matrix can hold any number of transforms at once. As an example, consider Object 3D's rotation parameter. Here's a snippet of code from the Euler angle demo. The airplane's 3 rotation axes are each set. This means that the airplane is first rotated around its z-axis, then its y-axis, then x. Internally, a transform matrix is made for each rotation, then these are multiplied together. Matrix multiplication works like this. For each location in the resulting matrix, you take the corresponding row of the first matrix and the column of the second matrix and perform a dot product between these two. For example, to compute element n24, I compute the dot product of the fourth row of the first matrix and the second column of the second matrix. This gives this set of terms here, added together gives n24. 16 dot products later and you have the resulting matrix. To multiply together our 3 rotation matrices, we can start at either end, multiplying Rx by Ry or Ry by Rz. I've decided to start with Ry and Rz. Multiplying these together, we get some temporary matrix U. We can then multiply together the X rotation matrix by this temporary matrix. This gives us another matrix, call it Q, which consists of all 3 rotation matrices multiplied together. This resulting matrix Q can then be used to transform coordinates. When an object coordinate is transformed by this single matrix, the coordinate in fact is rotated by the 3 rotation matrices in turn. It's clearly more efficient to use a single matrix than 3. The scale and translation parameters in the Object 3D class do the same thing. They create matrices and these all get multiplied together. Here's the full sequence of transforms that happen for an Object 3D when using its parameters: scale, the 3 rotations, and translate. Internally, these matrices are all multiplied together to give a single resulting matrix M. The parameter in the Object 3D class is in fact called matrix. You can now see why I've been listing the order of matrices as from right to left, as this is the order we use for multiplying them together. Multiplying matrices together like this is called concatenation.